Okay, so we're told that we have 3.00 moles of a substance. We're told that the specific heat at constant volume, CV, is equal to 27.0 joules per Kelvin per mole. And we're told that the change in temperature is 50.0 kelvins, an increase in temperature. And then we're asked for constant volume. A, what is the heat transferred? Now, heat transfer is given by NCV delta T. And we actually have all these, so this is a very simple substitution. We've got 3.00 times 27.0 times 50.0, and that gives us 4,050 joules of heat added to it. Now, part B says how much work is done. Now, this is a constant volume process, so the volume is not changing, and so there's zero work done. And now part C said what's the change in internal energy? Well, that, due to the first law, is Q plus W, so this is very easy again. It's just this plus this, which is 4,050 joules once again. And now in the second part we said for constant pressure, the change in temperature is the same, and we're asked to calculate these things again. So D, E, F. Well, the easiest one to answer is the change in internal energy. That's because it doesn't change. The change in temperature is the same, and the change in internal energy is only dependent upon the temperature. So we have the change in internal energy is equal to 4,050 joules. Okay, now to get the heat added, we'll need to use NCP delta T. And to get CP, CP is equal to CV plus R delta T. So now we can just substitute in here. We've got 3.00 times 27.0 plus 8.314 times 50. And solving that on the calculator, we end up with 5,297, or to three significant figures, 5,300 joules. Okay, now E, we'll need to use the first law of thermodynamics. We've got our change in internal energy and we've got the heat added. So the work is equal to the change in internal energy minus the heat added. So that's 4,050 minus 5,300. Solving that on the calculator, we end up with minus 1,250 joules as our work done in this case. And finally, we ask for the adiabatic case. And again, we're asked for GHI, where G is the heat transferred, which this is adiabatic, so by definition that's 0. H is the work done. I is the change in internal energy. Change in internal energy, once again, because the temperature change is the same, the change in internal energy is the same, so that's 4,050. And so the work done, in this case, the change in internal energy can't be due to the heat transfer, so it must be due to the work. So this will be 4,050 joules. And that's the answer to this problem.